But maybe like a lot of people, when you think about NFTs, you think about images. So that's the next thing we're going to look at. What's nice is I know we spent a while on the previous lesson, but a lot of the patterns that we just used are going to repeat. So prerequisites are the same. What we're going to do is mint a classic Cardano NFT by following the standard outlined in CIP-25, which suggests that we can use metadata like this. Here's the label. To mint a Cardano NFT that follows this standard, the label has to be 721. And then the rest of this metadata object, everything between these curly brackets, has to follow a very specific format. First, we have a key representing the policy ID. This has to match the policy ID that we just generated. There's a new object here. This object can have many asset names. We're going to create one that just has a single asset, but it's possible to have a whole list of these with new asset names. And that's how you can generate a single minting transaction with many NFTs in it. Okay. Each of these is going to have a unique name, a unique image. The media type will be consistent across the entire mint. The description can be whatever you want, and it might be same or different depending on your goals. Files, this is optional, but really recommended to include it. This is what allows us to have like a thumbnail of an image and a higher quality, maybe full-fledged image. I don't usually distinguish between these, but if I was building a production grade NFT series, I would want to have a high resolution image here and then maybe like a lower res image here that can load quickly into somebody's wallet. And then you can see right here, other properties. This can be anything. And this is where NFT creators have expressed all sorts of great ideas, right? We can put rarity and traits and all that. As long as it's structured like JSON, you'll be able to use it. We're not going to do that part here, but if you're interested in it, this can be a really nice thing to explore. In the next lesson, we are going to claim that metadata that follows this standard can't be updated, which is a little bit misleading. We can use this version right here to advance the version number of the artwork on an NFT, but it doesn't remove this data. It just replaces it. And that's how the standard works. We seek the precedence of the greatest published version ID at the metadata key, at a particular policy ID, and at a particular asset name. Now, why does this all work? This works because app developers have decided to follow this standard. It's arbitrary that this exists, and there's nothing on the blockchain that insists that metadata look like this. What does insist that metadata looks like this? Wallets, applications, exchanges, right? Anywhere that is presenting this data in a user-friendly way is safe to assume that the creators of an NFT followed this standard. That's what makes it a useful community standard. But there's nothing on the blockchain like there is for inline datum or reference inputs, for example, that says we must follow this. It's just that if you want the pretty picture to show up in your wallet, yeah, you have to, because that's how tools are built. So in the same way now, we can follow through on a transaction build, right? We've already seen how to mint tokens in the previous module, And even in the last lesson, 203.1, all we're going to do here is add one line, some metadata JSON file. And that's what you're going to see in this example. We're going to take two steps here. First, we're going to just experiment with preparing metadata. And then we're going to use the script that looks somewhat similar to the one we were just using to mint the NFT. To use this script, there's an example command down here. And this one takes 4 arguments as compared to the previous example where all we needed was the address. 1, 2, 3, 4. Where are these? They're at the top of this script file. The receiver address is argument number 1. That means it's the first thing we add after the file name. Then, oh, and I have to update this comment right here because it doesn't have all of these. Okay. The second parameter is the name of the token. Maybe we can name one after this lesson. Then we have some art. In most NFTs, this is going to use some kind of perma-web storage like IPFS or Arweave. And just like I can add any arbitrary URL, I could also add IPFS : / and then the content ID of a file on IPFS. And you can explore those documentations. That's one of the assignment suggestions you'll see at the end here. But just know that really the URL doesn't matter, okay? It can be a Web 2 URL like this one, or IPFS, or an Arweave address. And then here's some description. This is going to end up in the description field of the metadata. Now, after we define all these things at the top level, we're actually going to pass them as arguments to another script. So remember how we sourced the env and the utils, right? This is so that we can have some secrets like the path to assigning key. This gives us some helper functions like get address biggest Lovelace. But in addition to sourcing other files like this at the top of a script, we can simply call other scripts throughout our work right here. That's what we're doing with Cardano CLI. Hey, call this other program called Cardano CLI, do the transaction policy ID thing, and output a file. Then use that file. So right here, you can see that we're actually pulling in another script that's provided, and we're passing it as well a policy ID, a name, a URL, and a description. Let's play with this guy first, okay? That's step 1. So I'm going to exit out of this example from the first lesson. And you can see that there's another example right here, mint NFT with image. I just had this on the screen. But before we play with that, we're going to mess around with write NFT metadata. Let's open that one. Okay, so what does this do? There's the 4 arguments that we just looked at. And these are pulled in to this nifty echo trick again that outputs a metadata JSON file. And this right here follows what's described in CIP-25. It doesn't do all the fun other properties stuff. I'll leave that to you as an exercise to play around with adding traits or colors or anything else if you'd like to. This is a bare bones NFT minting policy. We create a new file, and then we're going to use it. I left this here. This shouldn't be here. Okay. Oh, I know why that was there. All right. So let's use that script first just to see what it does. Okay. So write NFT metadata. A policy ID is usually a 56 character string, but this script is not validating any of that. So I'm just going to make my policy ID like AF, 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 just so we can see it. Okay. What's the next argument? I'm just checking my notes. It's the name of the token, right? So we'll just say my new token name, so it's easy to identify, a URL, example.com, image.png, and a description with a lot of exclamation points. Okay, so what's this going to do? It's going to write a new file called metadata dash my new token name, because that's the param I put right here. Let's look at that new file. And what you see right here is that we have the 721. We have what's not really a policy ID. This is just showing how it works. Now we have a token name, and then we've got the metadata associated with this policy ID and token name. The description didn't work correctly because it terminated at the space. Okay, so I got to fix this script. We would rather have a description here that was that full string. And I see that the provided script didn't work. I'm not going to troubleshoot that live right now, but that's a nice thing that we can fix. And if you're watching this video, I encourage you to take a look. Now, another thing that you'll see here is that this image string is now in some hard brackets. That actually doesn't make a difference in terms of the on-chain functionality. But what this accounts for is how strings are handled in transaction metadata. The maximum length of a string is 56 characters when it's included in metadata like this. The problem is many URLs or IPFS URIs are longer than 56 characters. When that's the case, what you can do is you can split the string up into a list of strings, none of which exceed 56 characters in length. And just to show an example of this, let's run the same example again. My new long token name, right? And right here, I provided a silly example of like a long URL in the lesson notes. Let's just grab this guy. I don't know why that's showing up there. How's that? There we go. All right. So what you're going to see if I now metadata my new long token name. Yeah, the description's still not working, but you can see right here that we are splitting up that URL into the first 56 characters and then the rest. And if this was a real URL, this would work on chain. Great. At the end of the day, because the script is already written, it's pretty straightforward to use it. I'm just going to copy from the course notes this command right here. Here's the name of the script I'm calling. I'm going to send it to my browser wallet. I'm going to give the token the name lesson 2032, and I'm just going to throw a Gimbalabs G on it. And I'm pretty sure this example message is not going to show up correctly because spaces are not accounted for in my helper function. But for demo purposes, this will be fine. You can see that it works. And once again, first, let's review what happened. We already talked about these 4 arguments. We're generating keys just like before. We're saving the script path and the signing key file path just like before. But we're using a trivial minting policy. This one is just like in module 202, when you learned how to mint tokens for the first time. And notice that this no longer has the deadline part. Once we have that script file, we save the path as a variable and we pass that path to the transaction policy ID function, which can output a currency symbol. And there we go. That's our policy ID. The rest of this looks just like the previous example, or this part. The metadata is generated here. We just looked at that and compare this to the transaction we were just looking at. There's no validity interval on this one, so we don't have the invalid hereafter part. Where can we see that? Right? There's no invalid hereafter deadline slot like we saw in the previous example. I know that's really small. Right? So we're skipping this part. But we're including this time the metadata. And here it is once again. Okay. We still need a required signer because that's what's specified in our policy ID. We get both signatures and we mint the transaction. And let's see if this token is visible. So I just received a lesson 2032 token. There's actually the time locked token that we were talking about earlier. Here's the lesson 2032 token. And if I look for this one, you can see that it has the gimbal G attached to it. And here's the metadata we just published. Okay. Cool. So that's another script to play with. Of course, when you use it, you might want to send it to an address that you have access to so that you can view it, and you can replace the image URL with any other one that you want to. And you'll know you're successful if, like I just showed you, you can see that image in your browser wallet.